right, I think we'll get started now. All right, thank you all for coming. So this is a talk about Amazon Web Services S3 and kind of my personal experience with it. So first off, before we start, let's do a quick show of hands. So if you consider yourself like an S3 newbie, if you have no knowledge of it, yeah, just raise your hand. Okay. All right, that's kind of the audience I'm really looking to kind of talk to today. And any S3 experts in the audience? All right, okay. So a little about myself. My name is Sunil Kaulgi. I'm the founder of Outclip, which is a startup focused on video sharing for remote teams. So we basically use S3 for storing all of our videos, and it's really important to keep the security of these videos. In fact, most of my conversations with prospective customers very quickly goes into the security of the platform. So this is something that's really important for Outclip. I have over 2 years of experience with S3. And if you want to get in touch with me, that's my email. So this presentation is really a practitioner's take on Amazon S3 and how you could use it potentially for your projects or your company. First, a quick primer on S3. So S3 stands for Simple Storage Service. So it's one of the most widely used web services by Amazon. As of 2013, they announced that there were nearly 1 trillion objects stored in S3. It's probably grown by an order of magnitude, or maybe even a few orders of magnitude since then. So a common kind of misconception is that S3 is like a file system, but it's actually an object storage system. And there are some differences. For instance, S3 has a flat global address space, unlike a file system where it's a hierarchical address space. So for instance, in a file system, you've got a concept of folders and files. There's no such thing on S3. Everything is an object. So if you have something stored in S3 as prefix / file name, the prefix is not really a folder. There's no concept of folders in S3. Another thing that's different between an object storage system like S3 and file systems is that with S3, you get customizable metadata. So if you think about your files residing on your computer, you've got a fixed amount of attributes. You've got when the file was created, when it was last accessed, modified, who created it, and so on. And often these things you can't add new attributes, but object storage gives you a lot of customizability with respect to metadata. And this is a really powerful feature that you'll see where it comes into use. Just to kind of give a different perspective, if you look at a pricing comparison between like storage solutions, if you buy Dropbox, that costs about $10 per month for a terabyte. Compare that with S3, so that's $23 at a minimum for a month. And the reason is you've got nearly a 2.5x kind of premium you're paying for S3 is because of how powerfully like flexible it is and all the programmability and everything. So that's really the premium you're paying for it. Now, with great power comes great shared responsibility. So Amazon has this mantra of like shared responsibility, and that's their security model. And what this kind of diagram here is really saying is everything in orange is what Amazon manages, and the stuff in blue is what Amazon's customers need to manage. So Amazon is saying, hey, customer, it's your responsibility. You've got this powerful kind of abstracted service called S3, and it's really your responsibility to keep your data secure. And Amazon gives a lot of different ways in which you can ensure security for your data. So kind of just observing this diagram a little bit, you have the kind of the orange stuff. You've got the platform and application management. So all of that is run by Amazon. All the way up to the server-side encryption. So Amazon natively supports encryption of data at rest. Anything beyond that, you want your own client-side encryption. That's something that the customer is responsible for. And all the data, of course, it's really the responsibility of people using S3 that need to secure it. So just to give an example of like here are two kind of URLs for S3. Right? So the URLs have a standard format. They have something called a bucket. We'll get into that soon. So you've got a bucket name .s3.amazonaws.com / whatever object you've stored at that location. So here I've got two objects like stored in two different locations, and we'll see how when you try to open these files in a browser, what happens. I use the word like object and file interchangeably, but for the purpose of this presentation, they're the same thing. So let's copy this link. So you see, so I'm able to access this kind of object or file which is stored in Amazon S3. So it's basically open to the public. Anyone can view it. Then I look at this other file. And you get an access denied. Okay. To me, this is sweet music as a system builder. I want to keep files private. So this is really kind of what I do on a daily basis, is trying to secure data for our customers. And we'll see how we can get to that point where you take a file that's typically publicly accessible and kind of make it private. I want to just take a few examples of where kind of S3 kind of security has been compromised. So S3 is highly configurable, and most of the S3 data security issues and leaks happen due to misconfiguration. So let's have a quick trivia round here. So I just pulled out this paragraph from a legal document, and it's basically one party making a complaint against another. Any guesses as to what the two parties are? Yes. Okay. So you notice the rider and driver. So Uber is the party that's someone's complaining against. So this is the FTC. So the Federal Trade Commission filed a complaint against Uber because they did not adequately secure their S3 buckets. So as a result, a number of the drivers, like nearly 100,000 drivers, like personal data was compromised. And the reason it happened is because apparently one of the Uber engineers committed or checked in the access keys to S3 into GitHub. And that's a mistake that happens a lot. And there's hackers constantly scanning GitHub to find S3 access keys because that's free money pretty much. And in this case, a lot of personal information was compromised. Another case, we've got the World Wrestling Entertainment. So they had this huge trove of data for marketing purposes stored on S3, and they ended up leaving them public. So like you saw, the video I showed earlier was a public video, and companies don't want to make any of their kind of objects public, but it happened in this case. So kind of taking a step back and thinking about software security, right? So what are we trying to achieve? So software engineering, I really like this kind of way it's been expressed. Ross Anderson's Security Engineering, that's a great book. I highly recommend. Software engineering is about ensuring certain things happen. Security is ensuring that they don't happen. And a lot of times, systems fail because designers protect the wrong things, or they protect the right things the wrong way. So for instance, if you take one of the fiascos we talked about earlier, right? Maybe kind of those companies went at great lengths to encrypt their data and everything, but they couldn't stop their engineers from committing access keys to GitHub. So you need to look at different aspects of the problem and have a holistic approach to security. And also, we need to kind of really clearly articulate what the security goals are, and that's how you get good security for your system. So I found this to be a really good framework to reason about security. So if you're talking about security and trying to come up with a good security engineering, these four things need to come together. You need to articulate a policy, like what are the security goals, right? Like what objects need to be publicly accessible, which ones need to be private, and if they're private, like should specific parties be given access, who should not be given access? These are things that need to be very explicitly defined up front. And the mechanism, how you're going to achieve the policy, like you've got encryption, you've got several other kind of approaches that S3 affords. Now how are you going to use those to implement the policy? You also need an assurance. You need to think about the angle of, are these mechanisms robust, and can I use them for achieving the policy? And you should also look at the human angle, right? There are human actors involved. There's people who are employed by a company. There's attackers trying to break into your system, and you need to understand their motivations, and try to frame a security policy that kind of meets your overall needs. So kind of using that framework, I'm going to focus on this for this talk mainly on the policy and mechanism, because that's really where S3 kind of gives you a lot of options. So here's a policy that a set of policy goals that I have outlined. So we want to be able to deny access to everyone, right, except some users, right? You want to keep the content you store in S3 only available to a certain audience. You want to sometimes be able to encrypt data at rest. Some companies have a compliance burden where they need to prove that the data sitting in the database is actually encrypted. There's also cases where you want to encrypt data before you push it into S3, because maybe it's sensitive data and you do not want, if the S3 gets compromised and someone gets hold of the data, you don't want them to make sense of it. In some cases, you want to control read access to a file through a special file URL. I'll get into why you want to do this, but it's a fairly useful thing. And sometimes you'd want to control read access to files without changing the URL. That's another approach. And we'll get into all of these during the talk. Now, a quick S3 primer. So like I said, S3 is a simple storage service. And in S3, you store objects, right? So it could be an MP4 video file. It could be an image file, text files. I've heard people store database backups into S3. So that those are like binary blobs. A bucket is really a container where all your objects go. And to control access to the bucket, you have something called a bucket policy, where you basically outline, it's a statement where you say, these are the operations you're going to allow in the bucket for these, and these are the specific people who are allowed to access the bucket. AWS also has a separate identity and access management system that's abbreviated IAM, and it's good to kind of have a good grasp of IAM because it's useful for all the services that you use from Amazon. And there are different, and you can also, the operations you can perform on S3 are list objects. So you've got a bucket with, let's say, 10 files, and you want to say list objects so that it lists all the names of those files. You can say get object, right? So when I pasted that link, the video link in the browser, that was essentially a get object on S3. It's requesting for the file. And put object is how I put that file into S3 in the first place. So the different ways to access S3, you can do it through a command line interface. You can also do it through a web console. You can go to a browser and they've got a GUI where you can configure things, set up things. And you also have an API for programmatic access. So the get object, list objects, those are all part of the S3 API. So let me just quickly show you give you a brief tour of the S3 web console and the CLI. So this is an S3 management console. Here I've set up various buckets for the purpose of demoing. Probably increase size. So you see these are 4 buckets in my S3, and if you click into those buckets, you can see like the files that are stored here. And like I mentioned, right, S3 does not have folders, but if you look, if you see this one, they've got some sort of a folder structure, but that's just a GUI kind of syntactical sugar, you can say, where they're kind of making it easier for people to kind of access files and nest files and so on. Okay, so this is how you would access S3 on the web console, and if you had to for instance, this is really tiny, so I need to change this. Okay. Okay, so you've got AWS in the command line. So you just install the AWS SDK, and you can like type a whole bunch of commands. So for instance, if I want to create one of those buckets that I showed you, I would do the profile tech fest is just the way I've set up the credentials to access S3, and I can say S3 make bucket. So and this shows you all the commands that are accessible. So the command to make a bucket would be mb, and then I can type S3 bucket name. So this is how you would go about using S3 through the command line interface. Okay, let's get into the first of the policy goals that I outlined, which is deny access to everyone except some users, and let's see how we go about doing that. So there are different ways to manage access to buckets. You have what's called a bucket policy, where you specify kind of who can access the bucket and what operations it can perform and so on. There's also the IAM policy, like I mentioned. AWS has this kind of identity access management system. So a policy associated with that is also called the user policy. And you've got ACLs, which is not the ACL tear, but your ACL from the access control list. So when S3 gets a request to access an object, it first makes sure it goes through all of these policies and it combines them in a certain way to determine whether the user has access, is authorized to access the object. And I'll get into how exactly it does that. So to compare, so here's I've included the bucket policy and the IAM policy. So on to your left, you see the bucket policy. The things it mentions are listed here are effect, right? So you want to allow or deny access. Principal, so these are the users and the parties who need to be given access or denied access, for that matter. Then you have action, right? So action could be specific API calls. I want to limit the user to just the get object call, for instance. Then I would list S3 get object under action. In this case, I've used the wildcard character, so I can perform all operations on the S3. And resource is really what bucket am I referring to? Like I showed you in the previous console, there were like 4 buckets. So this is where you specify which bucket you're talking about and which bucket this policy applies to. On your right-hand side, you see the sample IAM policy, which is the user policy. And here, the difference is the principle is missing because you attach the IAM policy to a user. So it's already kind of implicit who the user is. So apart from that, you can specify kind of whether the user is allowed or denied access, what actions the user can perform, and what resources they have access to. Now, if you look at the access control list, so access control lists they're a legacy access control mechanism. They're not as flexible as what you can do with a bucket policy. So AWS recommends that you use bucket policies as your primary means to set access controls for your bucket. But the ACL does have a place. Like the bucket policy, like the name suggests, is a blanket policy for the entire bucket. But if you want to have a specific you want to set the access for a specific object, then you would do that through an ACL. So I have a picture here of a sample access control list. So this is kind of the group and whether this group can access list objects, write objects, read permissions, and so on. So you can specify which accesses you want to give to the specific user or group. Okay, now we talked about like 3 different mechanisms, right? There's a bucket policy, there's user policy, and there's ACL. Now who wins, right? Because they could conflict each other. So the way it works is it starts at implicit denial, right? So by default, just don't give access to the user if he's requesting for an object. And then look at all the policies and check if any of the policies have an explicit deny, right? So like I kind of previously showed you, the bucket policy has a field called effect where you can specify whether it's allow or deny. And if it's a deny, that's an explicit deny to the user. If there's an explicit deny, the answer is outright deny the user access. But if there's no explicit deny, then is there an allow? And if there is, then go ahead and give access to the object. And if there is no explicit allow, then the decision is a deny. So the access is really based on the least privilege union of all these permissions. So now I'm going to show you on the web console kind of where the bucket policy kind of resides, and also the access control list. So let's take an example. So this is the client-side encryption demo bucket. If you click into it, you have permissions. Under permissions, you have bucket policy. So you can click here, and this is the bucket policy statement, which I showed you on a previous slide. And this has the effect of allowing. It allows everyone, so it's a wildcard. So this is like open to the public. And the action is, you can perform any action on this bucket. And this is the specific resource. So we are in the client-side encryption bucket, so that's what is explicitly specified here. Now, if you take a look at the access control list, it's got a few options. You can set the ACL on a bucket, on the bucket. You can also set it on individual objects. So you can set the ACL for an individual object as well. But I'm mostly used to setting the bucket policy, and I think that gets most of the job done. And you typically will not have to kind of modify the access control list. Okay, now we're moving on to like how do you write a good bucket policy, right? Because this is really the foundation of securing your data on S3. So the kind of the principles kind of you need to follow are explicitly deny everyone except select users, and then you need to explicitly allow those select users to perform very specific operations. So you really want to give them the least privilege necessary to do the job. So to give you an example, like you'd want to deny everyone but allow Alice to execute a get object on the bucket. So that's a sample kind of good way to kind of articulate a bucket policy goal. So to show you how a good bucket policy is written, let's look at this other bucket here. Okay, so this is a slightly more complicated bucket policy compared to everything we've seen so far. So here we start with a deny. So there is an explicit deny for everyone for these two actions, get and put object, for the signing demo bucket, which I just opened. But the condition is unless the user is the specific user ID. So this is the kind of user ID associated with my account. So I've said deny everyone except my user ID, and explicitly allow these operations for my user ID. So the combination of these two policy statements results in only me having access to this bucket and no one else. Okay, now we're moving on to the next items on our list for implementing our policy, which is encryption. So you have primarily two options when it comes to encrypting your data. There is server-side encryption. So Amazon S3 encrypts each object at rest with a unique key. So Amazon makes server-side encryption absolutely transparent. So even if you enable server-side encryption, when you ask for an object from S3, let's say, hey, give me this S3, I want this video file. It returns you the video file, like being after it's decrypted and everything. So this is server-side encryption from what kind of from talking to people and meeting with Amazon experts is primarily a compliance necessity. It's not when you request S3 for data, it's always decrypted. If you want data coming out of S3 to going in to be encrypted and coming out encrypted, you need to use client-side encryption, where the onus is on you really to encrypt the data before you put it in S3. So the object is encrypted by the client before it's sent to S3. Now you know that with encryption, you're using a private key to encrypt your data. And that key management is really hard because every client has got their own private keys, and you probably want to use private keys per object. So that's a hard problem, but Amazon makes it easier through another service called the Key Management Service, or KMS. Okay, now I'm going to show you a demo of both of these. So to enable server-side encryption, you need to, so we go back to our S3. This is our kind of the main, the dashboard. From here, we can drill into a specific bucket, and we need to go into the properties for the bucket, and then you can, you have a default encryption op selection here, and you can select any option you want. So you can set up AES 256, and this, you can do it even when a bucket is already in use, and it's going to encrypt data at rest for objects that you add after you've enabled this setting. So this is server-side encryption. It's fairly straightforward. You just need to kind of change one setting, and you're good to go. Client-side encryption requires some work. So I've created this kind of web app as a demo. So what's happening here is, in fact, you can open these on your computers too. It's techfestdemo.online. It's a live web app. So the encryption here. So this is the operation where we're gonna take some data. Like we're gonna enter a file name here. So this is going to be, let's call it new file, file contents, right? So I'm storing a text file in S3, and I can store the file and its contents as plain text. So which is what I'm doing here, and the file upload is complete. Now I can I have this another operation here which reads files from S3. So when I say download file, okay. Yes, I have misspelled the name. Okay, so in the first tab, I wrote a file to S3 called new file, and then here I retrieve the file from S3. Now, if I choose to kind of encrypt the data, right, at the client side, I can select encrypt, and then I upload the encrypted file. So the encryption is happening in the browser in this case, and you look at decrypt, and I try to read the same file. I haven't selected the decrypt option yet, so let's see what happens. So it gives you kind of encrypted data back, right? So this is the thing what I fetched from S3, but I can choose to decrypt it in the browser, and that returns you the plain text. So the encrypted object is stored, and we'll get into how exactly this is achieved. So what's really happening with client-side encryption is you've got the user, right? They've got their application up, and they create a file and they want to store an encrypted file into S3. So the user fetches a private key from the Amazon Key Management Service, right? So prior to this, you should have set up like a master key in KMS. So there's some configuration that happens beforehand, but at this point, the user has got a file, and then requests KMS for a private key. And once KMS returns a private key, it also returns a separate, it's called a ciphertext blob. So it's got the key, it's got the blob. The blob is basically to identify the private key, and you'll see where it comes into use later. So the user then uses the private key to encrypt the file, and then proceeds to write the encrypted data to S3. So this is how you do client-side encryption. And in addition to, I mentioned, right, the KMS returns a ciphertext blob. So that blob is written as metadata to S3 for the file object. So there's some sort of a handle that is stored along with the file, which refers back to the private key that is used for signing it. So when you're going to decrypt the file, you first download the encrypted data from S3, and then you go to KMS and you pass it the ciphertext blob that you get from the file's metadata, and then KMS returns you a private key that you can then proceed to decrypt the file. So it's a bit involved, but if you want encryption, this is what you'll need to do. Moving on to fourth on the list, which is managing access through a special URL. Now the question is, kind of why do we want a special URL? So every object has a unique URL. Okay, let's call it a normal URL, right? So that's the, like I opened in the browser, there was a kind of the video file in the bucket location. That's the normal URL. But there are cases where you want to deny access, like if somebody uses the normal URL of the file, you want them to get an access denied message, but you want to allow access through only special URL that you have created. Now, why is a special URL needed? Well, you can achieve several things with it. So you can without having to change the bucket, you can have a really strict bucket policy that denies everyone except a very specific user. So without having to relax kind of the restrictions in your bucket policy, you can use this kind of backdoor by providing a special URL to the file. With a special URL, you can also attach a start and expiry date. So that's kind of like, if you think about it, Netflix, right? Some movies come and go, and Netflix is a huge S3 user. They're probably storing movies on S3, and maybe they would have a special URL for each movie, which says, like, make this link active like 5 days from now, and then make it expire like a month from now. So you can achieve all these kind of granular kind of expiry and start date objectives through the special URL. You can also have condition-based access. You can say, hey, this IP address or this range of IP addresses can have access to the files. And all of this is possible through a special URL. Now how exactly do you do that? So there are two ways to do it. S3 provides a native way approach that's called S3 pre-signed URL. So a pre-signed URL can be used to both get and put objects, right? So I want to block access to my bucket for everyone, but hey, if you want to upload a file, just ask me for a special URL, and I'll give you this one-time permission. Hey, I'm going to ask you to upload a file to this specific URL, and they'll be able to do it because that's what a pre-signed URL is meant for. The thing with pre-signed URLs is you can only specify an expiration date. An alternative approach is to use a CloudFront signed URL. Has anyone in this room worked with CloudFront? Okay, I'll get into it. I've got a CloudFront primer as well coming up. So this gives you a little more flexibility with, although you can only use CloudFront for getting objects, you can specify a start and expiration date compared to just the expiration date for the pre-signed URL. And you can also restrict it to IP addresses and a range of IPs and so on. Let's get into like what is CloudFront. So CloudFront is the content delivery network service from Amazon. Its primary advantage is it allows faster access. So I mean, this is a standard way to kind of speed up access for users across the globe, and it does it through caching. There's another advantage that comes through using CloudFront, and that is it gives you an extra layer of having your kind of security policy, and that extra layer of security policy basically provides two features, which is signed URLs and signed cookies as well. I'll be talking about signed URLs, but here's what CloudFront really does. So you could set up CloudFront in a manner that the end user is only requesting for objects through CloudFront, right? If the end user tries to access S3 directly, they will not be able to do that. So they're going to get it denied if they try to type in an S3 URL, whereas if they try to type a CloudFront URL for your object, they're going to be given access. And we'll see how this is done. Okay, so this is the S3 pre-signed URL, right? So I have this bucket called signing demo bucket. It's stored on S3, amazon.aws.com. That's how you tell like data is in S3. And the object is an MP4 file. And I have a video element here on this page. And the video element source is set to this URL. Now, it says error cannot play video because I've set the permission such that you cannot access this file directly from S3. but I can use S3 to generate a pre-signed URL. So if I generate the pre-signed URL, it's able to access the video. So it automatically switches up the source for the video element, and you're able to play the video. So if you notice, the prefix of the pre-signed URL is exactly the object that we want to access, right? It's at the same URL, and then you've got this whole bunch of parameters which specify who's given access and a signature saying like when, along with the expiration date for the URL and so on. And if we toggle this again, you won't be able to access it because you're going back to the normal URL. Now, so this is the S3 pre-signed URL, which is one of the ways of generating a special URL. And this is quite easy to do with an API. You just need to say S3 dot get signed URL, and then you pass in the normal URL for which you want a single special URL, and then it returns that. The second approach I listed was the CloudFront signed URL. So if you notice, this has a CloudFront URL. So it's like this unique string .cloudfront.net, and that's how you tell that you're accessing a file to CloudFront as opposed to S3. So using the S3 signed URL function, I'm able to kind of block access to the normal URL through CloudFront, but if I toggle it to a signed, then it actually gives me a special URL that I can use to access. And this URL, if you kind of look at the parameters, it's got a signature. It has which key generated the special URL and so on. I can toggle it again, and the normal URL does not work. This one works. And the way this is done, so the pre-signed URL is fairly straightforward. Like this is code that's running in a browser. It's all JavaScript. Whereas the signed URL requires you to set up a backend which you request for a special URL, and then it uses the CloudFront API to generate the URL and send it to you back. That's why you saw the progress spinner for a bit. That was basically the request going out to the server and then waiting for it to respond. By the way, all of this code is, I put it up on GitHub. So if you go to this kind of link which is publicly accessible, you'll be able to look at all the code kind of underlying that web app. Okay, so we covered both the S3 pre-signed URL as well as the CloudFront signed URL. Now on to the last one, which is you want to manage access without a special URL. Now why is this needed, right? Like what extra kind of facilities does it give us? So there are sometimes cases when you want to give access to users to multiple objects, right? And imagine if you had to generate like a special URL for each of those objects that requires like taking a normal URL, calling an S3 API to kind of sign it, and then it gets pretty intractable. Like imagine if you had 10 users and each user you had to give access to like 1,000 objects. That's like 10,000 signings that you need to do, right? That's like server time, and it gets expensive. So S3 gives you a different approach for dealing with this kind of problem, and that's what signed cookies are about. So this is a feature again that comes from the CloudFront service. So you've got CloudFront signed cookies, and here so similar to signed URLs from CloudFront, you've got signed cookies as well, and they basically allow similar policies as the signed URL. So you can specify things like when the date when you want the link to be active until the expiration date, and to which a range of IP addresses and so on. But there is also an important difference. The signed cookie policy can use a wildcard character, which basically represents a whole set of files. While the signed URL is for a very specific object, the signed cookie is really targeted at any files like with a certain prefix. So here's an example policy where the policy is one of the inputs into the CloudFront API for generating a signed cookie. So the signed cookie is a little bit more involved because you need to set up a server. You need the user to request the server for I need access to this range of files, and the server then responds with header information that contains the cookies that need to be set on the user end in order to access those files. Okay, so this is the last slide. I want to quickly summarize kind of all we have covered. So AWS, the important takeaway is AWS has a shared responsibility model, which kind of puts a lot of responsibility on part of their customers to secure the data. And S3 misconfiguration is often the root of the data leaks you have from Amazon S3. Now, we covered several mechanisms to protect data in S3 and that enable a whole range of policy options, right? So to quickly go through these, you want to be able to deny access to everyone except some users, and you do that through a very restrictive bucket policy. You want to encrypt data at rest. That's quite simple as like just flipping a setting on the bucket. You can do it through the web console. Encrypting data before sending it to S3. So that's client-side encryption. So there's a web app where in the browser you work with an Amazon key management system service, and that's fairly easily done as well. So all the data going in and out of S3 is encrypted. You can also control access to a file through a special URL, and you can also control access to multiple objects without changing file URLs. So kind of understanding all of these mechanisms is really key to kind of implementing good security for S3. So if you're able to kind of articulate your security policy goals, you should be able to use some of these mechanisms to kind of achieve those goals. So it's that is my objective here, is a whole bunch of things that I learned during the course of kind of building product for our startup, and what's been useful for us, and these techniques are actually kind of in use in a production app today. So I'll end right here, and I'll open the room for questions. Yeah.
So if the S3 misconfigurations are mainly, I guess, I would assume due to user error, is there something on the Amazon side being done to kind of assist them in not having those misconfigurations?
That's a great question. So Amazon's gotten better at it. When I started 2 years back, you had less queues to say that a bucket was left open and so on. But now there's, if you look at the, I mean, visually, if you look at the console, like things have changed. Like for instance, on the dashboard, it says like these two buckets are public and these are not public. They also have the system called a trusted advisor, and that kind of does it scans all your kind of access keys. It sees if anything's left open, that sort of thing. So the trusted advisor is a pretty useful tool for kind of doing a quick security scan of kind of all your settings and making sure that you're not left anything inadvertently exposed. So you can, this is what I would recommend to check out. So apart from kind of these tools that Amazon provides, I guess you really have to educate yourself on kind of the best practices, and manual audits are very important. So you need to, like the bucket policy and things, you need to keep it simple and make it kind of very easy to review and that sort of thing. It's really important to have a process in place. For instance, you could say that we're going to revisit, make sure that all our users have multi-factor authentication, and you want to say that we're going to review our bucket policies on a regular basis, maybe monthly. So it's good to have all of these policies, process in place. And I believe there are a few kind of third-party tools available as well for scanning buckets, but I haven't used any of those, so I can't comment on that. But for instance, yeah, so this is the trusted advisor. It already flagged that I do not have multi-factor authentication set up on the root account. So that's trusted advisor working for you. It's got a bunch of warnings, and it tells you what else is okay.
The case you're covering is when the user is already set up AWS through an identity manager.
That's right. That's right. Yeah.
What does it look like when you want to tie the policy to the user when they're coming in through an identity provider?
That's right. So AWS has a service called Cognito, which lets you, it manages the user pools and so on. Let's say you have, so I need to make a distinction here. So you've got the AWS account, right? So that's what the, since the developer would sign up for, and you can additionally add users to the account. That's one example, and then the way you manage those users is through IAM, essentially. Now, if you're managing your users, or customers, for instance, right? So they won't be on your AWS account as such, but they're using your service and they have a login and everything. So Cognito has native kind of email-based login, username-based login, and everything. It does have a third-party login, which is called OIDC, which is the OpenID Connect, I think. That's like an open standard for third-party sign-in services to kind of plug into Amazon as well. So if you set up your Cognito such that, let's say you've got users who are signing in through Google, then you could have, you need to provide certain information about the Google kind of, I think they need to, Google typically publishes a whole bunch of, a JSON document that says, talks about keys, encryption keys, and all that stuff, and you need to somehow link that into Cognito, and it's fairly easy to do. And once you do that, you can have your kind of Google users like identified within the Amazon system, and from there you can go and proceed to setting up like the bucket policy, right? So you go from third-party login into Cognito, and that once you have a native kind of Amazon identity, then you can use that identity to set your policies and so on.
So in that case, there's some property that's being passed in by the identity provider that links them to a certain bucket?
That's correct. That's correct, yeah. So you could, now one thing I did not cover here is the identity access management has something called an IAM role, all right? So it's, instead of a user, it's a role. You can specify a policy for the role, and you can make users signed in through a third-party provider assume a certain IAM role, and then you can use the IAM role inside your bucket policy, saying that, let's give you an example. If my users are signing in through Google, and so Google, I tie in the Google identity provider into my Amazon system, and then I translate, once they're identified in the Amazon system, I can say all these group of users you associate with this IAM role, and then the role you can proceed to use it for kind of controlling access to Amazon services and so on. More questions? All right, thank you very much. Yeah, I hope you liked it. Yeah, thanks.